you so much, Mike, and to the team at NSRR for the organization, the invitation to the organization. So I'll share screen and basically take a few introductory minutes before really handing it to Márton, who will handle most of this session. I will briefly mention where this project comes from, what was the incentive in creating it, and where it stands within our laboratory at the Technion-IIT Institute of Technology, and then a short introduction to PPG, and then handing it to Márton, who will introduce the toolbox in details with you. So this toolbox is part of a suite we started working on already quite a few years ago within a framework called, or software called Fiducial. It has 4 toolboxes, one for oximetry analysis, one for ECG analysis, one for heart rate variability analysis, and the most recent one for PPG or photoplethysmography signal analysis. So these toolbox were developed over quite a few years, as I mentioned. You have kind of the timeline here and used for analyzing also sleep data, not exclusively, but certainly in our own work or work of people who use our toolboxes. A lot of sleep data were analyzed, and of course, from the NSRR resource a lot. What did they have in common? So the general efforts here was to make sure that everything was open. So all the code, source code, is open source, as well as how we validated the toolbox themselves, like the different functions. By validation mean that we spend quite a lot of work making sure that what we implemented reflected the original biomarkers that were developed by others, by the original papers. And we documented that quite extensively. And finally, above the source code of the toolbox itself, the libraries, we implemented also user interface, which I'm displaying here for heart rate variability analysis. Heart rate can come from the ECG or can be derived from PPG as well. So you could derive your beating rate from PPG and then make this type of analysis, looking at beating rate variability over a long recording, such as a sleep recording. So you see here the interface, like the beating rate, the window that is selected for the analysis. The statistics you see displayed below are computed over the selected window, and you can, move through the whole recording all night and derive your features that way. So it's both for this interface is both intended for people who are maybe less coding people or developer, or for visualization as well. Helps us a lot within our own lab for visualization purpose. So you see here some of the statistics and graphs that maybe some of you familiar with heart variability analysis will recognize. Anyway, so that's the overall framework. Same interface for SpO2 analysis, for ECG analysis, and deriving important fiducial characteristics. And of course, on PPG, and Márton will elaborate in a few minutes. This is part of our lab, the Artificial Intelligence Medicine Lab at the Technion, in contributing back some of our work to the academia and the researchers. So we have 12 open resources, including 7 toolboxes and 5 medical datasets, plus 3 more that we are opening soon. With that, I'm transiting to PPG. I will give some introductory words here. This introduction may be repetitive for those of you who are already familiar with what PPG is, but it's necessary for those who are not familiar with what PPG is. Often, PPG is associated with pulse oximetry. The reason why is because pulse oximeters are based on PPG measurements. This is what the source, the raw signal that they measure. There are two ways to measure PPG, at least to mainstream. One is through transmission, and the other one through reflectance. What it means is you have an LED throwing light at your finger, and a photodetector on the other side of the finger, which is sensing the light that is transmitted, that has been transmitted through the finger. So basically, this the amount of light that is being absorbed here is modulated by a pulsatile component, which is the artery blood flow in the microcapillaries you have in your finger. So basically, as blood flows through your finger, you have this modulation of the arterial blood circulating, which is affecting how much light is being absorbed and thus transmitted. And so that's why the PPG waveform that we record looks something like this here. It is pulsatile, synchronous with the heartbeat, and has a shape that Márton will elaborate more on. The second one is through reflectance. Okay, so this is the reflectance scenario. You throw some light by an LED to the finger, and you basically sense how much of this is being absorbed in the finger, but through reflectance this time. Now, I mentioned pulse oximetry. Very briefly and simply, pulse oximeters are measuring what we call SpO2, oxygen saturation. Oxygen saturation is a ratio of oxygenated hemoglobin over the total hemoglobin. So there are two unknowns. You need two variables, two LEDs at two different wavelengths in order to estimate this SpO2 ratio of oxygenated hemoglobin over overall hemoglobin. So that's why in oximetry signals, you will see that there is at least two LEDs that are placed on the probe of the oximeter. Now you will all be familiar with PPG as being measured now on wearables, particular smartwatches or smart rings. This you can easily, if you have a smartwatch with you, take it off, look at the back of the smartwatch, and you will discover these photo sensors and LEDs I just mentioned on the back of your smartwatch. There may be one, there may be a few. It depends exactly what the manufacturer is doing with the signal. But the bottom line is that this is a technology that is embedded in wearable signals or wearables devices, and that is recording PPG. One word which is important to keep in mind when talking about PPG, at least for regular clinical measurement, is that it can be measured on different spots of the body. The finger is probably the preferred spot, but sometimes for various reasons, this may be measured on the ear or on the foot, and even on the chest, in some companies. But there are different spots, basically, where PPG can be measured, and this affects the shape of the signal, because the perfusion will not be the same on your fingertip versus on your ear tip, etc., etc. So that's something important to keep in mind. And the toolbox we developed with Márton and Dr. Peter Charlton at the lab, it was developed or was validated for finger PPG. It may work very well with other with PPG measured on other spot, but we haven't investigated it ourselves, and we would love if some of you have tried to get some feedback from you on whether this worked well for you. If you are interested in learning more about PPG and its application in healthcare, I really redirect you to this rather major piece of work we published a year and a half ago, the 2023 Wearable Photoplethysmography Roadmap. It talks about the technology, the signal processing, the research direction moving forward. So I really recommend looking at this piece if you are interested in digging in. With that, so I will handing it to Dr. Márton Goda. So briefly introducing him, Márton was a postdoctoral fellow within my laboratory at the Technion. This is where he developed, together with Dr. Peter Charlton, who is affiliated with Cambridge, the Toolbox that he elaborated on. Now Márton is an independent researcher and professor in Hungary, where he specialized in physiological signal analysis, signal processing, machine learning, for both like PPG in sleep recordings, fetal monitoring, and more. And so I will hand it to you, Márton, from here. We can't hear you, Márton. I think you need to unmute.
Okay. Can you hear me?
Yes.
So, thank you very much, Jane, for this introduction, and Mike for this opportunity to a little bit introduce to you the pyPPG toolbox. I'm trying to share my screen. Can you see it?
Oh, and sorry, just to say, there's a question in the chat that maybe you both can answer it, and it's which signal is relatively higher accuracy? I guess it's talking about the pass-through versus the reflectance.
Yeah, so clearly it's the transmission one is better than reflectance of signal quality. Now reflectance is eventually, if you have a smartwatch, then that's what you get. So in my opinion, this PPG that you will obtain with a finger oximeter or at least a smart ring will be superior to what you can get with a smartwatch.
And again, just before you begin, Christoph, just you can open up the Q&A box and you can see the questions as they're asked.
Okay. So,
Okay, thank you. I can see them.
welcome everybody. So currently, as an assistant professor at the Faculty of Information Technology in Péter University in Hungary, and as Jay mentioned, we worked together 2 years in Israel between 2022 and 2024. During this time, we had also collaboration with Peter Charlton in Cambridge, and one of our work was to develop an open source Python toolbox for PPG analysis, standardize everything what we can know about the signal in the literature, and hopefully give a tool for researchers, developers to help the home monitoring variable devices. So, as James mentioned, the PPG signal is an optical measurement which is generated by the blood ejection from the heart, and it's influenced by several effects like heart rate, natural ejection, and also the microvasculars, including also the peripheral compliance and resistance. Don't forget that the autonomic nervous system also very important part of this regulation. The influence the heart rate variability. The respiratory system is a main component also, which can affect the signals. So all of this together is very important part of the PPG signal, and there are lots of potential also because all of this together can somehow reflect to the PPG signal. So it's a as you can see in the market, in the or in the researches, there are more and more researches about the PPG signals. There are more smartwatches, fitness trackers, home monitors we can use for blood pressure estimation and so on. So that's why it was very important in our work that we develop a standardized toolbox. And one of the challenge was to make a high performance PPG detector. Previously, Peter Charton benchmarked the top PPG detectors, and what we found that one of them is the Aboy implementation was very strong, but this implementation was not that fast. So the first step was somehow speed up this original implementation, and after that we started to add other features to the toolbox itself. So currently in our toolbox we have 15 Fiducial points. These are the standard Fiducial points for the PPG signal. It's included for the original PPG signal and the higher derivatives. And also we extract the state-of-the-art biomarkers. These biomarkers has several physiological effects also. For instance, the pulse transit time reflecting the blood pressure and the arterial stiffness. The reflection index indicates the peripheral vascular resistance. The aging index estimate the vascular aging from the PPG second derivatives. The diacritic notch, what you can see here, the diacritic notch reflects vascular tone and so on. So as you can see here, the first step was to detect the important Fiducial points like the systolic peak. Usually for heart rate estimation, we use this Fiducial points detection, but actually the pulse onset and offset is very important if we are speaking about the heart functions. So and higher derivatives also have important Fiducial points. As I mentioned, some of them relates to the aging index. Here is our publication. We published this paper recently. It's more used, and I'm very happy to help you if you have any question regarding to the toolbox itself. So Today, we will start with a general overview with the pyPPG toolbox. I will introduce the main components of the PPG signals. Next, I'm gonna move to the how can I extract the Fiducial points. I'm gonna show some uh, uh, um, basic commands, what you can use to the toolbox, calculation, the biomarkers, detecting the fiducial points. And finally, we will see in a machine learning case study is especially for apnea and hypopnea classification using the PPG biomarkers. For more details, you can click on the pyPPG Reader Docs website. Just a minute. Open also because we're gonna continue here. Just a minute. Okay. So this is the main page of the pyPPG toolbox. Here is a general overview what you have to know about the PPG signal. What are the main requirements for the toolbox? We made the validation. It was very important for the fiducial points detection because there is a limited opportunity for the fiducial points validations. So you can also check this part. Here I detailed the main databases what we used to our projects. So first, let's check with an example. Here, what you have to do that first, you have to install the Python 3.10. It's important because the package compatibilities the 3.10 is working with properly with each Python packages. Here you can click, you can download and install. I'm not gonna do it because I already installed on my computer, and I hope so that you already have it on your computer. So please do this if you wanna follow with if you wanna follow with me the next section. If you already have it, then the next step is that you have to download the sample data. Here you have to select the sample PPG CSV. Oh, it doesn't matter, but we can use the MOT format. And here, if you click, you can download the signal. I already downloaded. So yes. So I go back to the main page. The next step is you. I try to make this tutorial as simple as possible because I know that you came from different backgrounds. So, of course, all of these steps, what I'm showing to you, you can do it also in a specific IDEA, PyCharm, and I can Jupyter notebooks, whatever you want. But for this tutorial, I made in a very simple way to introduce to you the capabilities of the toolbox itself. So first, we're gonna open a command line. Okay. And what we're gonna do that we're gonna create a virtual environment. It's not necessary, but highly recommended to avoid the package conflicts if you have other projects. So what I used to do that when I start a new project, I just create a new virtual environment. It makes much clearer the project itself. So you can write py. I'm gonna use the 3.10, so minus 3.10 minus n minus m and virtual environment and PPG and less will be the name of the virtual environment PPG. Okay, it takes a few seconds. You can do also all of this virtual to create a virtual environment through your idea, your PyCharm. If you are a little bit more advanced in Python, I can recommend to use the mini conda because it makes much comfortable to create your environment and handle your environments. So after that, we created this environment. What we're gonna do that we activate this environment. So we write PPG and is the environment itself / scripts and backslash activate. So as you can see, here is the activated environment. So it's an empty environment. We can install whatever you want. If you are ready with this one, the next step that we have to install the pyPPG toolbox itself. So we're gonna write again PPG script Python dot exe minus m pip install pyPPG. So it takes also a few seconds to install every necessary packages. What is important when I created this toolbox, I tried to make it as compact as possible, which means what you can see in the requirements txt, it's already built in the during the installation, so you don't have to care about which version of the NumPy you need or which pandas you have to install and so on, because I automatically call this requirement txt. So when you install the pyPPG toolbox, you install technically everything what you need. So you are ready with the installation, as you can see. And the next step is to run an example code. This example code includes everything, every features, every biomarkers, what we use in the pyPPG toolbox. So first, what we have to do that we open a Python interpreter. So we write just Python, so you can use it, and we import the example module from the pyPPG toolbox. So from pyPPG dot example example import.
I'm sorry to
Yes,
interrupt.
yes.
There is a request to zoom in on your terminal window.
Okay. 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 Is it more visible?
I think so. For my needs, it is.
Okay, I'm
Yes,
sorry.
it is. Okay.
Okay, I'm sorry. I'm sorry. My screen resolution is much bigger, much higher, so that's why I didn't notice. So, from the pyPPG toolbox, we import the example module, and we import PPG example. Okay. So it takes also a few seconds. I hope so that it works also for you. And if it's done, we just have to run one command, the PPG example. And that's it. Oh, I'm sorry, might I miss example. Okay. Here you're gonna get in a pop-up window, and we can select the signal what was downloaded. So, and the program automatically calculate all fiducial point in the first stage. You're gonna get this figure. Okay. And you can see how it works. Okay, so the first signal is the PPG signal itself with all fiducial points, which means the onset and offsets. It's technically the same, just the next onset is the next onset is the previous offset. The red circle is the systolic peak. We can see the diacritic notch with the green square, and the purple one is the diastolic peak. Here you can see the first derivatives and its fiducial points, the second derivatives, and the third derivative. If you close this window, then the program automatically calculates each biomarkers, and where you created your virtual environment, we are created an awesome temporary directory, and you will see all results. So in the first folder, you see the definitions of the biomarkers. You can open it in Excel, actually in CSV. So here you can see the how many biomarkers we have. You can see the name of the biomarkers, the definitions, and the units. Let's see. So this is saved. We calculated the statistics. You can check the fiducial points. And the good news is that if you already have your signal in a MAT format, with this view command, you can easily calculate every fiducial point. So here is the index for each pulse wave, and the fiducial points for in sample. Let's see how it works in the biomarkers. here you can see the results of the biomarkers for each pulse wave. So it's the first, second, and so on. And what is important that we have four type of biomarkers. If you dive a little bit in the details in the documentation, you're gonna see that we use the biomarkers for the original PPG signal. There are some ratios and modified calculations. It's a derived biomarkers. It's the second category. The higher derivatives also have also a type of biomarkers, and the different combination of these higher derivatives in a fourth category. So the next part is if we are done with the investigation. Oh, here you can see the saved figure. Okay. So this is the last figure before we close our panel. Okay. So when you're ready with this part, I recommend to exit from your Python interpreter and deactivate the virtual environment. So you can do all of this virtual environment in your own IDEA or server, whatever is comfortable to you. But I think this is the simplest way if you are just starting to be familiar with the Python. So in this short tutorial, you have successfully installed the pyPPG on your local computer, run example code, and export the result itself. After that, feel free to customize the toolbox to your own project. I hope so that it was clear enough for you. But if you have any question, just feel free to ask, write to us in the chat. The next part of this workshop is to look at the basic commands. In this session, we will go through the same example, what we saw here, but we dive into the command itself. So if you click on the comprehensive PPG analysis, I already created a Google Colab notebook. Just click on it. Okay. And you have to scroll up to the top. Okay. So, and we're gonna see every part of this toolbox little bit closer. So the first part is to load the raw PPG signal. It can be any format. I mean, not any format, but it can be MOD format, CSV, TXT, or EDF format. And these are provided by the toolbox. In the documentation, you can see how you have to store your data if you want to use these formats. The second part is the Fiducial points extraction, which includes the first of all, to prepare the data, the filtering, and the extraction, the Fiducial point itself. The third part is the Fiducial point plotting, what we already saw in the previous example. The fourth one is the biomarker extraction. It has 74 biomarkers in 4 categories. The first one is the PPG signal characteristics. The second is the signal ratios. The third one is the PPG derivatives. And fourth category is the derivative ratios. And fifth part of this module is the biomarker statistics, which means that we summarize according 9 statistical parameters, statistical metrics or biomarkers. We make a signal quality assessment after that, and we can easily save the data. So first we have to run. I'm sorry. I just have to use normal browser. Okay. Just a minute. So first you have to install similarly the Python itself. I used here in a specific version for the Python because when I created this toolbox, it was on a forgiven version, this toolbox. And meanwhile, when I modify or make updates for the toolbox, I can also modify the final comments. So what I'm saying here that when you're using in your restart, when you're using the pyPPG, you don't have to care about it. Just for this case, I used the specific version, and also I forced to use the specific version of the SkyPy. This packages recently updated, and not all of this are compatible with everything. So it takes a few seconds. You don't have to care about these warnings. So after that, you have to import the required components. So here, actually, I imported each modules, the preprocessing part, the Fiducial points, the biomarkers, the signal quality assessment. Also, we have to import other packages which relating to the toolbox. And here in the next part, we download the PPG data itself. It's I already uploaded for Zenodo. So if you click here, you see that we downloaded the data. So you don't have to, again, care about it, how you save it or not. Okay. If you already have the signal, you have to define the path of the signal, which is actually the root directory of your Google Colab. You can define the beginning and end of the part. In Python, if you define -1, it's the last sample of your signal. I call the saving folder like save directory, and I prefer the CSV format for saving. Okay, so we load in the next session the PPG signal. I used only 20 seconds. It's more than enough for us in this example. After that, we use a simple matplotlib library. So we plot the PPG signal. And in the next session, we do some preprocessing. So this, what you can see, this is the original PPG signal. As James already mentioned, we are we work mainly with finger PPG signals. And we validated mainly for this our toolboxes. But in general, there is a optimal frequency band for the PPG signal. The lower cutoff frequency is 0.5 because we want to avoid the baseline wandering of the signals, and the upper cutoff frequency is at 12 Hertz. I use the four-folder IR filter. It's in the original implementation was used a fear filter which was implemented by Peter Charton, but actually we also validated and checked that this four-folder IR filter is good enough to get the filtered PPG signal. And after that, I did some smoothing for the higher derivatives, and I encompass everything in one class in this signal, which includes the PPG signal, the first, second, and third derivative, the velocity accelerated PPG, and the York. So if you already run this section, then you can plot the derived PPG signal. So as you saw, it's already filtered. If you scroll back a little bit, you see here was a very strong baseline wandering. We already resolved somehow. And the next step is to make some correction for the to set a few things regarding the Fiducial point detection. This is not necessary, but during our validation, we found that in certain cases, the original onset detection has to be corrected. It's a type of development for the algorithm. And you can choose it because it's not all the cases necessary. But in our validated dataset, we used the correction for the onset, the diacritic notch, diastolic peak, and the VW and F Fiducial points detection. So we can run this part. We create the PPG class and we put it in the S variable. We initialize the Fiducial package, and after that we extract the Fiducials. Here are some warnings not relevant for us, and here we put all Fiducial points. So when you're ready, you can plot the Fiducial points. This plot Fiducial points is also part of one of the module in the PPG signal. By PPG, which automatically generated a temp directory for the figures and for the other saved data. So after we have the Fiducial points, we can make a very easy and simple heart rate estimation. We calculate the number of the beats, the duration. We have to define the duration in second, the heart rate. And yes, it's important that you have to run again everything. However, in Colab, it's this history is stored because I have to load again the functions, the variables. Otherwise, I can't use the next functions. So we make a signal quality assessment. As you can see, the signal quality of this PPG signal is very good. So the signal quality is important that it's calculated for one pulse wave. And when we calculate the signal quality, we calculate actually the mean signal quality. And if you have it, you can initialize the biomarkers and you can extract very easily the biomarkers based on the Fiducial points. So we had for the biomarkers, we needed the signals and the Fiducial points. And what we return is the general statistics for the 9 statistical parameters, the values of the biomarkers, and the definitions. And it's very convenient that you run again only just one code, one command, and you can get everything. Yes, okay. And if you are done, you can already see here the results for the biomarkers. Here is the 9 statistical metrics, the mean, median, standard deviation, the quartiles, and so on. And if you're ready, you can save everything in the temp directory. I close it and I open. Okay, so here you can see already the biomarkers. It's exactly the same what you saw previously. And we can see the Fiducial points. Yes, we can see the figure what we created. And if you want to download your data, you have we can create a zip file from this temp directory, and you can click on it, and you can easily save to your computer. So again, I already have it, and that's it. So that was the second part. As you said, this 2 example was very, very similar, just in different aspect. And the reason because I tried to show you these commands that you can be confident and you can customize according to your purposes. This toolbox. And for the next session, what I did that to have a look for the Physiozoo itself, because the Physiozoo is, as Jay mentioned, part of in a collaborative platform. It provides multiple physiological signal processing analysis, and it's integrated in Python, in MATLAB. So if you are working more comfortable in MATLAB, then it can be very useful. So previously, I made a short summary about the pyPPG, which is integrated in the Fiducial. So in the next few minutes, I would present to you this short video. Just a minute.
Welcome to Fiducial PPG. My name is Dr.
Wait.
Márton Áron Goda, and this short video.
We're not really seeing the video, we just see the website.
Okay. I hope so.
Welcome to Fiducial PPG. My name is Dr. Márton Áron Goda, and
can you hear it? Can you hear it?
Okay.
Okay.
Short video, I will present to you how can you use the Fiducial PPG for time series analysis. Fiducial PPG is a platform for morphological analysis of photoplasmogram signals. First, visit the physiozoo.com website and download the example signals and the installer. After that, you have to run the executable of the Fiducial installer. We will start with the opening of the Pulse module from the main screen. Next, we will upload the signal that we want to process. In the Configuration tab of the top, you can set the primary parameters of the bandpass filtering, avoiding the unwanted baseline wandering and the noisy high-frequency components. During the filtering, we can set the order of a second-type Chebyshev filter. The Fiducial points detections were validated with 0.5 to 12 Hz cutoff frequencies and the first-order filtering. To compute the Fiducial points, click on the Fiducials. You can see the different categories of the extracted biomarkers. Under the PPG signal tab, you can find the representation of the typical intervals, amplitudes, and the areas of the filtered signal. The PPG derivatives tab represents the typical intervals of the filtered PPG derivatives. Under the signal ratio tab, you can find the typical ratios of the intervals, amplitudes, areas, and different combinations of these biomarkers. The derivatives ratios tab represent the typical ratios of the intervals, amplitudes, and the different combinations of these biomarkers. To save the Fiducial points, click on the file and save the Fiducial points. This will produce an Excel file containing the metadata and all Fiducial points for the PPG signal and its derivatives. To save the biomarkers, click on the file and save the biomarkers. This will produce also an Excel file containing the metadata and the 4 categories of the extracted biomarkers: the PPG signal, the PPG derivatives, the signal ratios, and the derivatives ratios. Thank you for watching this video. I hope this short tutorial gives an idea how can you use the PhysioZoo PPG fiducial point detection and biomarkers engineering. For more detailed information, please visit the physiozoo.com website. Goodbye.
Okay, so thank you very much for watching this video. So the next session is and a case study because you can ask, okay, why is it good for us to extract these biomarkers for fiducial points? And for this case, I brought to you one special study. What we also worked in our project. So this in this study, we worked with the MESA dataset, and we tried to investigate the apnea and hypopnea events. And the annotation was obtained from the National Sleep Research Resources. So one of the connection of this web seminar as well. So just so in this section, we will see how does it works to classify MESA in the how to classify signals using PPG signals. The apnea is in a complete pause in the breathing during the sleep, while the apnea is a partial reduction. Both last at least 10 seconds, and they can disturb sleep, lower blood pressure levels, and they are linked to the health risk. That's why it's important to detect them or at least investigate them. And in our original dataset, we had more than 2,000 patients, and we selected 263 obstructive sleep apnea, which includes more than 31,000 obstructive sleep apnea events. Each event was calculated by the processed by the pyPPG toolbox. We defined the first event of the sleeping at the sleep stage 2 until the last sleep stage. So that was the total sleep time. And in the next part, we will see the 5 main modules what I used to process this data. It's important that the biomarkers was already extracted preliminary, because you know that to extract biomarkers for so many windows and events takes a lot of time. So I already provided this data for you. So the first module, what I already shared with you, is the first one is the feature and label extraction for the selected records, model training and feature selection summary, the record visualization and eye shading, evaluation metrics, and the record generation. And the last one is the evaluation of the apnea versus hip apnea using the PPG biomarkers. It's important that we have to run each module separately, and after that we can use each module. And if it's a little bit slow, you can switch to the T4 GPU in Google Colabs. However, it's not guaranteed all the time. It's limited. So it just if you want to run a longer process, can help, but not necessarily. Since this is a standard Python notebook, you can easily run also in any Jupyter-supported IDE such as PyCharm Professional. Again, one of the reasons because I use this Google Colab because it's easily accessible. Later on, you can also play with this, or you can just export the notebook here, and you can use in your idea if you want. So the first module is the feature and label extraction. This module actually extract the features and includes the all features and the PPG types, and also this will use for the next module. The second part is the training and the feature selection itself. For this one, I imported the main modules for the important modules for the sklearn, for instance, the group shuffle split. You can set that if you want to use standardization or logistic, if you want to use logistic regression. We used in this example, I used the logistic regression. Again, this is one of the things what you can modify if you want to play a little bit. And for the feature selection, I used the recursive feature elimination to make simpler the classification itself. So this module is responsible mainly for the feature extraction itself, and it's a little bit longer module, but we store everything and we return back the number of the features and the model itself. The next part is the visualization. It's important that if we get the results, that how does it look like? Sometimes we just say a number for the drug analysis, but it helps a lot if we can see that actually how does it look like the final results for the true positive and false positive results. And for this one, we plotted the ROC curve and also the Q1 and Q3. Yes, here I customized the plot. Yes, I have to run also this section. I have to check that it was run or not. So this section was run. I have to run this one. Okay. I run the ROC curve visualization. So the next one is the evaluation metrics. and the ROC curve generator, which mainly calculates the ROC, the precision, the sensitivity, and specificity, the F1 score, and it helps to present the result. We put everything in one data frame because in this way we can much easier to handle the data. So here are the input for the get prediction results. Here are each modules when we calculate the median or precision are stored. And the final session is the evaluation itself. I have to run also this session. Okay. Just we can use the function. So the last module is the evaluation itself. So we want to know that the apnea and hypopnea classification, how it works. So for this case, I download the extracted features which were already extracted by the my toolbox, and you can see here are the features and also the labels. We have two type of signal. One of them is lateral, other the supine position, and we want to compare it how it works for the lateral and supine, the apnea and hypopnea classification. So and finally we can run our model. Here you can configure. I defined just a 3 iteration because it takes lots of time this evaluation, but if you want you can define much more, 10, 20, or even more than 100 or 1,000. It's significant. You're not gonna see a significant difference above 20 iteration. I selected the top 10 features. Might you remember that I mentioned that I used recursive feature elimination, and our selected types are the lateral apnea and lateral hypopnea. So here we compare the apnea versus hypopnea in lateral, and the other categories are the supine apnea, supine hypopnea, where we compare the apnea, hypopnea, and supine position. I choose the test size for 0.2. I use standardization. I customized a few things for the plot. And in this loop, you can just run this model calling the functions. And when it's ready, we can see the results. So it's for 3 iteration. Supine it takes time. We can see that the classification for apnea versus hypopnea, it's around 0.8. In case of the supine position will be a little bit higher. So as I told you, it's a little bit playground. If you want, you can try many other things if you want, based on this short example. And I hope so that it's very helpful to you for further researches or development. Yes. So What else? Um, I think that was the main or the core part of this case study. We have to wait a little bit for the results in case of the um, uh, in the case of the uh, supine position. Meanwhile, if you have any question, feel free to ask. Uh, and yeah, it's almost done. Yes.
While all this running, I have a small technical question.
Yeah, yeah.
It
Feel
doesn't
free.
necessarily matter for these analyses, but when you're doing the filtering, are you using zero phase filtering?
Yes,
Okay.
yes, I'm using zero phase filtering. So if you want, we can dive into. Oh, we can see here, but in the filtering. Uh, I what is I think is more important that we used IR filter, and what you see that here is not an exact 0.5 cutoff frequency. It's because the stability. The IR filter, it's one of the good point of the IR filter that the complexity is much less. On other hand, it can be unstable. So that's why we use this specific cutoff frequency, because this was stable for each validated signal. But keep in mind that in case of the IR filter, can be some disturbance in your signal, which not related to the signal, it's relating to the filter itself. And with this modification that we used the IR filter, I could achieve a significant acceleration with the previous implementation, and that's why it was very important. You know, the MESA dataset, it's a huge dataset with 20,000 our records, and it's really important that what kind of preprocessing you have. So to go back to the results, you can see in case of the supine position, the result is 0.83, which is a little bit better than the lateral position. So thank you very much for your watching. And this research was, as we already mentioned, supported also by Peter Charton, who helped develop the toolbox itself. During my postdoctoral research, I was supported by the estate of Sophia Friedman, funding by the Israel Innovation Authority, Network for Research Vascular Aging, British Heart Foundation, and of course by the Technion University Faculty of Biomedical Engineering. So thank you again for the opportunity to Mike and James, that I could a little bit introduce to you this toolbox, give you some perspectives, how can you use it for your researches.